LLMs are one of the most unreliable technologies of all time, right up there with Bluetooth and wireless printers. But this is not an unfixable problem. Let's cover my top secrets for making LLMs much more reliable than they are by default out of the box. Let's start with the Achilles heel of LLMs, hallucination. LLMs love to give confidently wrong answers, which lead to incorrect behaviors and frustrated users. But where LLMs shine is in summarizing information. One of the best techniques we've ever found to get around this problem is to provide the entirety of information the LLM should base answers off of directly in the prompt. So for example, for a bot that should answer questions about the Builder platform, we compile a list of relevant URLs to the question. These could be generic or also retrieved based on the contents of the question. We then pull down the info for the docs and explicitly tell the LLM, this is all the information you know. From this information, if you can answer the question with what you see here, please answer it. Otherwise, if you cannot get the answer from this information, say you do not know. LLMs are generally bad at being able to acknowledge what they don't know, but they're good at looking at information in a prompt and answering questions based on that information, such as if the answer to the question is in that information set, summarizing that information, or even transforming it to the user's needs. Those needs might be adapting the information in the docs to a specific user's problem, which if that information is in the docs provided, it could be fantastic at. And you may have noticed one trick we use here is we put chunks of information in XML tags. This is a useful technique to break up your prompt and make clear what set of information relates to others, so there isn't any ambiguity. By using this technique, you can go from problems like this, where Amazon's review AI will tell you about how to integrate Builder in your code, to what you really want, which is when you ask questions that we don't have answers for or don't want to answer, we tell you, sorry, we can't answer that. When working with LLMs, in general, you want to be as clear as possible in your prompts always. So for example, when we included this in our prompts, use links in responses for our assistant that answers questions about Builder. What we got were a bunch of hallucinated made-up links. What worked wildly better was to provide the entire set of links for our site with a brief description of what's behind each link, wrapped in XML tags so it's grouped together, and telling the LLM, use links in responses, but you only can use this set of links. That squashed the issue, and now we get the correct links always used and no more made-up hallucinated URLs. In general, the more examples you can provide, the better. Too many times I see people write very vague prompts that if asked of a human, they still might not be completely clear on what they're being asked. When talking to humans, we generally take abstract information and clarify it using a few examples. For instance, we have an AI assistant that updates visual content in Builder. We first asked it to use JSON patches, but it came up with a wide variety of ideas on how it should be doing that. A much better approach is to provide as many clear examples as possible of what good outputs look like. So instead we can say, here's some examples of what good patches look like for a given data model. So we say, hey, here's some JSON of an example model wrapped in XML tags. We point out this is JSON patch format. And then we say for given prompts, like to update the title fields, we're going to want to use the replace operation with this new value. At a cook time field, we're going to update the second field with this new value. And if we want to remove an item, we're going to use the remove operation with the path to the correct field. In our actual code, we provided about 8 more examples, and we got substantially better responses as a result. Given that LLMs these days support such large context windows, research like in this paper have generally found that a larger context with more high-quality examples can be as good if not better than fine-tuning with many, many examples. In my opinion, the nimbleness of being able to request information on the fly and provide those examples in real time, personalized to the user, generally beats out fine-tuning in at least every scenario we have applied this to our own products. An important consideration when building AI products is also not just the technology, but the user experience too. Given that LLMs are unpredictable and imperfect, you should never assume in your UIs that the first LLM output is correct. This is why you'll see so many chat interfaces like the one we use in Visual Copilot inside of AI products. We don't want to assume the output's correct and give the user the ability to be able to type in and submit any additional refinements they want. Like in this case, we converted a Figma design to code, but we're chatting to modify that we want tests in a separate folder rather than in line. Another interesting technique you can use when building with AI is what we call the microagent approach. So rather than letting the AI fail and requiring the human to always give it feedback until the final result is correct, in some cases you can automate the feedback process and run the AI on a loop. So in cases where you can automatically check for correctness and provide feedback to the LLM, you can let it iterate on its own until it lands on a correct result. With our microagent project, this is exactly what we do. In a CLI, you describe what you want and we generate tests, or you can use the ones you already wrote. And then the AI will generate code and then check if the tests pass. If the test doesn't pass, it will then feed the test results back into the AI and revise the code until all tests pass. This is one of the few cases where AI code generation gives you guarantees that it actually works as expected, rather than leaving it up to you to have to figure out what's wrong with this code on your own. We also use this internally inside of Visual Copilot to increase the accuracy of the Figma imports to the final generated code. The more we can check automatically, we do, so that you as a user don't have to do it manually. In general, when building with AI, remember one really key thing. As much as possible, do not use AI. AI is expensive, unpredictable, slow, and overall likely to give your customers a lot of headaches when things don't consistently work as expected. Try to break down your problems and solve as many as possible without AI. Yes, LLMs are the coolest, newest technology, but that doesn't mean that's what you should reach for everything. Use typical coding for more fast, scalable, deterministic, high-confidence areas. And in our case, we frequently train our own small models for specific specialized tasks that can be better, faster, cheaper, and more reliable, and combine those up into a larger solution. We use LLMs as little as possible, and when combining all techniques, traditional code, small self-trained models, and occasional large language models, you'll likely find a more robust, reliable, and scalable approach. And don't forget to get user feedback along the way. Nobody's going to care about your cool AI thing if it doesn't solve real problems the way people need them to. Build small, get user feedback, and refine. And of course, steal all these techniques I shared, as well as others I've shared before in past videos about training your own models, etc. And go build some awesome AI products.